করি, কারণ রেকর্ডিংটা চালু হতে আবার একটু টাইম নেয়। তো এনিওয়ে, in our last class we have discussed the what is called the work energy equation. We saw that there are two versions of the work energy equation, but we decided that we will be basically sticking to the second version. Stated in other words, the second version was something like that: 1 u tilde 2 is equal to delta t plus delta vg plus delta ve. So that was the equation, and the difference is that in this equation we need to take into account the spring into our system. That means the spring into our system we need to take into account, and accordingly you need to write your equation. So whenever in the exam you will be solving this type of problems, few things are very important to know, because if you do not write them, then full marks is not being awarded even after your answer everything is correct. The things are that, first of all, you need to show clearly where is your reference line or datum line for calculation of any gravitational potential energy, number one. Number two, if you write this form of the equation, then you need to tell that you are taking the spring within your system. For example, in this problem, when I analyzed it for the position 1 and position 2, there was no presence of spring, so I do not have to write anything over there. But when I am taking it for position 2 to position 3 in order to analyze the maximum compression of the spring, as I was telling over here, in that case you need to mention that the spring is well within my system. That means my system consists of this mass block and the spring both, and accordingly we will be taking this entirely it to be a system, and then we apply this particular equation between the two state points 2 and 3. So this was the problem which we discussed in our last class. Today we will take up couple of more problems in this chapter before we call it a day, and prepare ourselves to take up our next chapter in the class. So accordingly we take up our today's problem. This is our today's problem. It is taken for problem number 3/128. The characteristic of this problem is that the speciality, so to say, is that here, unlike the previous problem where we had just one mass, here we have two masses, or we can have more than two masses. So it can be, it is therefore to be noted that whatever equation that I had written here, if you see that our basic governing equation between two state points, I can write our basic governing equation in this manner. I can say that 1 u tilde 2 between the two state points, 1 being the initial and 2 being the final. We said that this is equal to delta t plus delta vg plus delta ve. Now this is true for a single particle, correct? Now when we have multiple particles, then this equation will get modified. Get modified in the sense that we have summation 1 u tilde 2. That indicates that it may be the all active forces other than that due to spring and gravity, which is acting, or rather which are acting on your system. Your system consists of multiple masses, and that then it indicates the sum, and obviously all these will be put under the summation sign. The summation will need to be done with the number of particles there. Suppose if you have, for example, n number of particles, then we need to sum it over n, right? Or rather we need to sum it over the sum n. So we just put the sum sign here. So you can say that this is, this all, for all particles we need to calculate this work done, and for all particles we need to calculate this change in kinetic energy, change in gravitational potential energy, and change in elastic potential energy. So with this idea, so this is actually true for, we can say, system of masses or system of particles. System of particles. In fact, in our last chapter of this module, I mean to say dynamics of particle, we need to take up system of masses. So system of mass particles, we need to formally go into the discussion of the system of mass particles over there. Here also we'll have this case, but here whatever this if in your case such multiple masses are coming, then mostly these masses will be having dependent motion. So in this case your masses will be having dependent motion. But when we take the system of mass particles, we will actually launch more general study where your mass particles not necessarily are having, yes.
Hello.
Oh, okay. Sorry. So, sorry. So what we have that we note that if you have what I mean to say is that in this case, whatever system of mass particles we are considering, all of them are showing the dependent motion. For example, in this problem, I'll explain it later when I'll be solving this problem. But just note that when I have, this is for a single particle, and the second equation I'm writing it for multiple particles, and in that case for multiple particles we are having the particles are having dependent motion. That means they are interrelated with some constraint equation. But when we will study the chapter of system of mass particles, which will be our last chapter in this module, and form the beginning or the foundation chapter for dynamics of rigid bodies, there we will have to discuss this problem of dynamics of group of particles from more general point of view, meaning that there the particles may not have the dependent motion. So all those particles will have independent motion. So with this introduction, so we see we just have this modification that we need to carry out this sum, what sum, and this change in the energy terms. We need to carry out them for all the particles that are present in your system. If there are n particles, we need to carry out this sum for n individual particles and write our resulting equation. Now with this introduction in our mind, let us now come and focus on to the statement of the problem. The statement of the problem is telling that each mass, each of the sliders A and B, so these are your slider, this is slider A and this is slider B, is having a mass of 2 kg. So both of these masses are basically equal and moves with negligible friction in its respective guide, with y being in the vertical direction. Correct? So this is in the vertical direction, and this we say x as the horizontal direction. So y being in the vertical direction. A 20 Newton horizontal force. So there is a horizontal force of magnitude 20 Newton that is is acting onto your system. And we note that a horizontal force is applied to the midpoint of the connecting link, midpoint of this connecting link of the rod. So this is the rod and its midpoint. This horizontal force of 20 Newton magnitude is basically acting. Now what we say that a 20 Newton horizontal force is applied to the midpoint of the connecting link of the negligible mass. So this rod is otherwise having no mass. If this would have possessed mass, then the motion, this problem would have been becoming the problem of rigid body dynamics, which we have not yet taken. So this can be also the problem of rigid body dynamics had the mass of this rod AD been included into our system. So, and the assembly is released from rest with theta equal to 0. That means if you make theta equal to 0, so it means that AD initially is completely along the y-axis. Okay, it is completely along the y-axis. And the assembly is released from rest with theta equal to 0. So that would be my initial configuration. We need to calculate the velocity VA of the slider A. This is the velocity which we have to calculate, with which it strikes the horizontal guide when theta becomes equal to 90 degree. That means when the entire thing would have fallen down here, in this case, we see that this is the horizontal guide that we are getting. This is the horizontal guide we are getting. And there you need to, at what velocity it will come and strike this position, that we need to calculate. So we see that here a couple of things are important to indicate that it is of having negligible friction. So I do not have to consider any friction force. Number one. Number two is that it is said that this y is in the vertical direction. So since this y is in the vertical direction, so it is pretty obvious to note that this would therefore, represent my the vertical plane. So this would represent the G. So the entire assembly is in the vertical plane, because then y will be the vertical direction. So we therefore now, instead of using this format, we will be going to use this one. So I have to see that this I need to calculate for both the masses. This is also for both the masses. This is also for both the masses. However, we don't have any spring here. So for us, our equation therefore becomes, little bit simplified. So what is our equation now becoming? I can write it something this way. I can say that my equation is summation. We can write this is sigma. We can say this is for 2. That means I have, say, I equal to 1 to 2. We can say this is 1 u tilde 2 I. That means all the work done by the active forces, all the work done by the active forces which are other than that force due to gravity and spin. This will be therefore summation. This will be therefore, it is summation of I equal to 1 to 2. This is delta T plus, this is, we see that delta T plus, we have, this is delta Vg plus delta Ve, and this we need to carry out for all the mass particles here. So since we do not have any delta V, I just take this to be equal to 0. So I set this is to be equal to 0, because in my case there are no the springs which are associated within our system. Now, in order to carry out this work integral or the work function, we see the only active force within this system other than the force due to gravity and spring. Since there are no springs, I just say that other than gravity, in fact, there are no the active force which is acting into our system except this 20 Newton one. So actually here, in order to calculate this work integral, I require only the work done by this 20 Newton force. Correct? So therefore, I see that this term will be equal to, I can just mark the situations. So this is our, we can say that this is our configuration 1, because the system, when it is being released, this rod was totally at vertical condition. That means theta was equal to 0. So this represents my first state, 1, and the second state would be obviously this position. So I should draw it with the different pen color so that you can understand. So let me draw it with a green color, showing you that this would be my second state when theta is equal to 0. This one will come and we call this as state 2. This is state 1 and this is state 2. So in between that, I am actually writing this equation. So essentially we see that when theta is equal to 0, right, the displacement of, I mean to say, this midpoint of this rod was here. This was the position when this rod is in state 1, and when it has come to state 2, so you see the displacement, then the midpoint of the rod, suppose it comes to this position. So what is the distance here of this midpoint? Let me see from here. The distance of this midpoint as it travels from state point 1 to state point 2 will be how much? Now that will be equal to 0.2 meter, because this will be the entire rod. The length of the rod is 0.4 meter, because this end will come here, this point A will come here, and this would be the position of point B, right? This would be the position A, this would be the position B, and the midpoint will be, obviously this A to B distance is 0.4 meter, so midpoint is 0.2 meter, and this force is of constant magnitude, and obviously it is always acting in the horizontal direction. So therefore we see that this first term, so I can write therefore that I just evaluate piece by piece these terms. I say summation I from 1 to 2, 1 u tilde 2 I is actually equal to the work done by this 20 Newton force. So it is therefore that integration from x equal to 0 to x equal to 0.2 into 20 times dx. So other words, it becomes 20 into 0.2. That means it is turning out to be as 4 joule. So that will be therefore the work done by the non-gravity, non-spring active force in the system. All other forces, that the normal reaction between these guides, the normal reaction here are all reactive forces. So in the active force diagram, we have just this non-gravity, non-spring active force is only one. So I have just only one integration to carry out, and this integration also is very simple because your force is constant, and therefore it becomes equal to 4 joule. So that is the work done by this external force. Now regarding the change in kinetic energy, because you see here that at time t equal to 1, we note that at time t equal to 1, we just consider that everything was at the condition of rest, because it was stating that it is initially being released from the condition of rest. So therefore, all subscript 1 for the kinetic energy, these terms will be equal to 0. Or in other words, we can say that summation T1 I varying from 1 to 2 is basically equal to 0. Because this sum is to be written for each individual I. So each individual I. So I see that for all of them, this is becoming equal to 0. Now comes the condition of 2. Now before I evaluate the condition of 2, let me just see, the thing that supposing if it is at some arbitrary angle, say at this position, theta, correct? So what would be the relationship between the two velocities here? So in that case, suppose if instead of this flat ultimate condition. Suppose if someone is asked that instead of theta equal to 90 degree, what would happen in the case when theta equal to 45 degree or theta equal to 60 degree, or in that way any theta, what would be the velocities? So therefore, in order to analyze that more general case, what we can do is something like this. We can instantaneously take the positions of these two particles, considering this point as our reference. This point, I mean to say the line of intersection of y and x, the origin. Say if we call this as the origin, then at any arbitrary position, this will be my y, right? And obviously, this will be my x. Yes, this, this will be my x. We can say this will be my x. So these are your positions, okay, for any arbitrary consideration. So I can write from here that say here x is equal to, I can therefore say that x becomes equal to, using this theta as my variable, I can write x is equal to 0.4 cos theta, we can, sin theta, and y is equal to, you can say 0.4 cos theta. So we can just see from here, if we differentiate these two positions, these two variables with respect to time, what I will see from here is something like this, x dot, that becomes equal to the velocity of this block B at any position where theta is this variable. We can write from here that it becomes equal to 0.4 theta dot, because theta is changing, it is not constant, cos theta, and y dot, that is equal to minus 0.4 theta dot sin theta. Now the significance of this minus sign is that it means the y and y dot are having opposite directions. So it means that I measure y in this sense, this is upward, and this negative sign indicates that the velocity of this one will be in the downward direction, correct? So, and that is the case here, that is the case. So you see, this is the, these are therefore the velocities. Now we note when theta is equal to 0, we note that when theta becomes equal to 0 from here, theta becomes equal to 90 degrees, when theta is equal to 90 degree, that means when this one is coming here, what I find is that the velocity of the block A, that means this y dot, this is going to be maximum, right? This is going to be maximum. That means this block is coming and hitting this. So if I see it this way, this is the end A. This end A is coming and hitting this with this velocity. This is the velocity VA, with which it is coming and hitting it at theta equal to 90 degree. That means it is at position 2. This is coming and hitting with this full velocity, because when theta is 90 degree, you see this becomes maximum.
Sure.
And interestingly, yes, bolo, kichu bolben?
No, sir. I just have bolla.
Acha, okay. So you see here at the other end, if you see, this is the position B. This was position A and this is position B. At this position, you see, if you put theta equal to 90 degree, what you are getting? You are getting x dot is equal to 0. What means is that when this rod is coming and hitting like that, this point becomes, I mean to say this slider here, it becomes stationary. Correct? So what therefore it is saying? It therefore says that our summation, we can write it in this manner. This simple observation tells that, and I can write that summation I from 1 to 2 T2 at point 2. That means the total kinetic energy at 2, actually it should have been equal to TA plus TB at position 2, correct?
Yes, sir.
And just now we note that TB2 here, we note from here that TB2 it becomes equal to 0. Why it is so? Because your VB2, velocity of point B at position 2, this comes out to be 0. As a result, we see that TB2 is basically equal to 0. So it means that I am having only the term, the kinetic energy that is due to this velocity. So I therefore say that this is basically equal to half into what was the mass for each block? The mass was 2 kg.
2 kg.
Yes. So it is half into 2 into VA2 square. So we can write like that. If I suppose this VA2 equal to V for simpler notation, if we just denote this velocity as small v, because I now see that only one velocity is surviving. So since there is the only one velocity, I therefore say that if this is V, then I can write this to be equal to, we can say that this is equal to V square. Simply it is equal to V square. So it essentially means that therefore we can say that summation I from 1 to 2 delta T I, that is equal to what? That is equal to, just because I say that everything at 1 is 0 and I just have this only for this one, so I can say that this is basically equal to V square. Because half into 2 gets cancelled and this is the only change in the kinetic energy term that we are getting. Why it is so? I repeat it. It is because at position 1, all these velocities were basically equal to 0, and at position 2, I am having only the velocity of the block A, no velocity for block B. This calculation, this part of the calculation actually establishes this one. This part of the calculation establishes this thing, that at this we are having this relationship. So from here, thus I can say that the only term that is surviving is this kinetic energy, and I can write therefore our total change in kinetic energy, that becomes equal to 0. Now in order to calculate the total change in the potential energy, so we can say, I can write it like that. I can say that summation, we can say that summation, this is sigma delta Vg I varying from 1 to 2 is basically equal to Vg2 minus Vg1 for particle 1 plus, we say that this is Vg2 minus Vg1 for particle 2. So this is the term that I will be going to write it in this way. Now, in order to calculate these individual potential energies, I need to consider the datum. That means where I need to consider the potential energy to be, gravitational potential energy to be 0. So I decide that this gravitational potential energy, for calculating this, I just take this as my datum. So this level as my datum level. As I said, these are very important. You need to show them all. Otherwise, even everything is correct for you, there is no marks, full marks for you. Sorry. So you say this is data. 1, your B is here. So it means that its potential energy must be 0. And at position 2, both of them are coming on the datum level. So it indicates At position 2, both the sliders, according to our choice, both of them have their potential energies to be 0. So remembering that, I can therefore see that considering this, I say that Vg2 is 0 for both the particles. So this is going to be 0. This is also going to be 0 for both the particles, Vg2. Further, we note that the second particle, I mean to say the particle B, you can say particle 1, you can take it as particle A, and particle 2 as you can take it to be slider B. So this is also 0. This is also, this is also coming out to be Vg1 at 2. Sorry, Vg1, not Vg1. Sorry. So I think I made some mistake. Let me check it once again. I say that Vg2 for particle 1. Oh, I'm sorry. I have made some. Actually, there is a complex notation. That's why this. At position 2. So this is position 2. This is position 2. Both these potential energies to be 0. So I say that this is position 2. Both of them are. Oh no, sorry. Actually, I made my own problem. This indicates the particle number. Sorry, and this indicates the second subscript indicates the position. So the second subscript indicate positions for particle 1. So this is 0. This is actually position 2. So this is 0 for the first particle, second position, and then we have second particle, second position. This is also 0, and then we have second particle, first position. So where is the second particle, first position? The second particle, first position is 0, already been taken care of. So you see, this is going to be the thing, and we say therefore that. Also, this represents what? This represents the first particle at the second position. Second particle at the first position. Second particle as the first position. So, second particle means the particle B. At the first position means it was here. So, it is also equal to 0. So, actually 3 terms are all 0, and we are only left with, this one, minus Vg11. Minus. So minus Vg11, therefore it indicates what? It indicates that first particle's gravitational potential energy at position 1. First particle, the gravitational potential energy, this is the first particle. This one indicates that it is first particle, and this indicates your position, right? So first particle at position 1, its kinetic energy is its potential energy is coming out with a negative sign, and I just put it here since it is at height of 0.4 meter from here. So y for me is going to be plus. So it means that initial potential energy here will be therefore minus. So you need to cautiously see the things. I am repeating once again, the outer bracket subscript indicates the particle number. 1 for particle A, I can write it here for you. 1 for particle A and 2 for particle B. We write it in this way. 1 for particle A and 2 for particle B. And the inside subscript, it indicates the positions. I mean to say the initial position, final position, like that. So the only surviving gravitational potential energy is this when it is at here, and obviously this is going to be minus 2 into 9.81 into the height. This is plus because we are in the upside with the datum, and how much will be that? That is 0.4. So we can say this is 0.4. We can write like that. So it means that it is minus 0.8 times 9.81 so much of joule. So you can calculate how much it is. If you do this calculation, how much will be? It is 9.81 multiplied by 0.8 gives me the value 7.848, So I can say this is minus 7.848 joule. Please check all the calculations. So this is your, okay, because you need to check it thoroughly. So you see there is a minus sign here. So that minus sign is there, minus 7.848 joule. So that is the thing. And we don't have any spring and etc. something like that. So if we just recall all these things and now assemble part by part the work energy equation. So I just see that if I assemble now, therefore we can say that it is 4, because the left hand side, remembering that left hand side is 4 joule. This is the value that we have already calculated. So we say that it is 4 is equal to how much? This is coming out to be V square minus 7.848. Or in other words, we can say that V square is equal to what? This is coming out to be as 4 plus 7.848. So that gives me the velocity with which the block A is coming and hitting the portion. That will be equal to how much? To it we add 4. So this is this thing, and then take the square root. It is coming out to be as 3.442. Okay, so 3.442 meter per second in the downward direction. That also you need to mention. This is your sense with which it is coming and hitting the block at this position. I have, of course, the book with me. This is the problem number we stated is how much? This is 3 by 128. So just going into the answer block, just cross check what is the answer. So you see this is little bit, I need to increase the depth. Oh my God, that becomes very hard. So it is this one. 3 by 128 is the problem sum number. So just go that way. It's long, so many problems. So 3 by 128, it's coming out to be, see, this is the problem. 3 by 128, highlight for you. It is 3A equal to 3.44 meter per second, and that you need to also specify, because you need to calculate. It is being asked what is the velocity with which the slider A is coming and hitting this thing. So you see this is the thing. So I think you have understood the problem. This problem shows how you can, handle multiple masses. Of course, they are having connected velocities. This connected motion is actually being represented this way. So this is your connected velocities. With which we can come and solve the problem. Now, couple of things are important to note. Here we have not it is because then unnecessarily, if we dismember this, unnecessarily the internal force that is developed because of the motion within this rod will be exposed, and that will act as the active force so far as the motion of the individual blocks are concerned. And we can later on, when we will see the system of mass particles in a more general form, as I have told you at the beginning of the class, we will show you that any internal force connecting the members, their work done is normally, not always, normally it is 0, the work done, but it is not always true. However, in this case it is true. Therefore, the internal work done by the internal force that will be developed in this slider, in the rod AB, that is not going to contribute anything in my work equation. That is observation number 1. Observation number 2 is that in this case we are very lucky, in the sense that we are being given 2 configurations of both of them are very simple geometrically. I mean to say the initial configuration is with respect to this angle theta, initial configuration was theta equal to 0 and the final configuration was theta equal to 90 degree. But as I was actually discussing, what would be the case when your this angle will be, somewhat general one. Say for example, as the motion starts, what will be the velocities of these two blocks at theta equal to say 45 degree? Or for that matter, since you are doing numerical analysis, someone can convert this problem and can give you a certain assignment that write a C programming code in order to find out the velocities of these two sliders for different angles with theta equal to 0 with step size theta equal to 10 degree or 5 degree. That means you need to therefore generate an output where you will be having this column theta VA. See how these things are getting interrelated with each other. This problem can be also a problem of your numerical analysis. Say I say theta equal to 0 degree, everything was 0, right? And now somebody is asking me that produce this history. That means theta equal to say 5 degree, then 10 degree. In 5 steps of 5 degree, you come theta equal to 90 degree and evaluate all the velocities of these two blocks at these respective angular positions. Do you get my point? That means what I need to say is that
Yes, sir.
looking at the table, I can take any arbitrary angle. For example, I say theta equal to 25 degree. What would be the velocities of these two blocks at that position? So you may be asked to write a programming code, and also you may be asked to develop a graphical plot showing you the variation of these two velocities with the angle theta. That means you need to draw a graph plotting velocity on the y-axis, say VA, and theta here. Similarly, velocity VB with the variation theta, or a single graph showing both the velocities as function of theta. So you may be asked to, have this problem. So under such circumstances, how you can actually handle the mathematics? So at any arbitrary angular positions, see, we note that the velocity, because I said that when I will be discussing here the group of particles or system of particles, I will be having the dependent motion. So here also the motion of these two sliders are basically dependent. How they are dependent? Because if you look at this equation, x is equal to 0.4 sine theta and y equal to 0.4 cos theta, which defines the positions of these two blocks, I can eliminate theta and can set a relationship which is looking like this. That means say which we can have this way, which we can write in this manner. So how we can just say, just adjusting my scale pen. Sorry. So you see here, I can write that x square, eliminating theta from the above, I can write x square plus y square is equal to, we can say 0.4 square. So this is, a constraint relationship. That means whatever your x and y be, you see they should satisfy this relationship. So what does that indicate? If I differentiate it with respect to time, this relation, we have seen such relations in our constraint motion chapter, kinematics. So if you differentiate this relationship with respect to time, what you are getting is something like this: x into x dot plus y into y dot. That turns out to be 0. Or in other words, we can say that x dot, and this is true for any position. And what is x dot? This is the velocity of block B. So I can say x, which defines the coordinate of block B, into velocity of block B, plus y, which defines the coordinate of block A, into velocity of block A, is becoming equal to 0. So it indicates that at any position you can see that the velocity of block B, I can write that it is equal to minus y by x into velocity of block A. So you see, this is the relationship. This is basically the relationship between the velocity of the block B and the block A. Correct. So it means that suppose if you are to find out this as a function of theta, so you can see from here that your velocity of block B can be written as minus your y is 0.4 and x is 0.4 sine theta. So from this I can write that this is basically equal to minus cot theta, VA into cot theta. So it shows that if I put any angle, I will get the relationship between the two blocks, the velocities of the two blocks. If I put any angle, the velocities of the two blocks will be interrelated by this equation. So therefore, if you take any angle as your variation, as your parameter, so if I am to find out the complete expressions for velocity of block A and block B as a function of theta, basically I can apply the work energy equation and can calculate the bit by bit the work done. Say for example, if it is in theta, how much will be this distance? We can say this distance will be, if this is theta, then this distance will be 0.2 into sine theta, right? That will be the distance. And how much will be the work done from this position to this position by this 20 Newton force? So it is obviously 20 multiplied by, this distance. Now you just cannot multiply it by this. You need to calculate it for small angle variation. That means if I call this distance as x, then this will give me, this dx will give me that, you see this dx, I just add a page here. So I can say, since x is equal to, we see that here, x is equal to 0.2 sine theta, I can write from here that dx, that becomes equal to, 0.2 cos theta d theta. So the work done, 1 u tilde 2, say this 1 u tilde 2 term is being given by integration from 0 to, say, any x, right? It is f times dx. Your f being constant, you can write this as 20 integration from 0, x being equal to 0.2 sine theta, and in place of dx we can say this is 0.2 cos theta d theta. So from there you can see that this we can write as 20 into 0.2 into sine theta. This 0.2 will come, so 20 into 0.2 will make it to be as, say, 4. So we can write it like that. It will be equal to 4 into sine theta. This sine theta term will be there. This sine theta term is there. So it is becoming equal to 4 sine theta. Because you see, this is the, it is actually, this limit I have written wrong, because it is written in terms of the theta, so I need to express this in terms of theta, so this is written in theta being any arbitrary angle. So you see your work done becomes 4 sine theta. So that is your work done by the constant force, right? Or you could have done this way, that since this x is equal to, turning out to be as 0.2 sine theta, 20 multiplied by 0.2, because this is constant, but still I show the integration process to keep in your mind that in order to calculate this work done, you need to actually basically integrate. It happens to be here, it's very simple. You could have multiplied these two and could have obtained the work done, but essentially it needs to be calculated through integration. So you see the work done is expressed as a function of theta. Then also you can express the gravitational potential energy, because you see here this block continues to be in this position, so it means we choose this as datum. So it means that this potential energy we can take it to be 0, and we can simply say this is the potential energy, and for that it can be also expressed as a theta, because y equal to 0.4 cos theta is supplied to us. So the potential energy for the block A for any arbitrary position is being given equal to 2 into 9.81 into 0.4 into cos theta. So even you can express the potential energy term there. And kinetic energy, when you are expressing the kinetic energy, you need to remember that your actual kinetic energy is considering that initial kinetic energy for both the particles to be 0. So the final kinetic energy consists of half into 2 into Va square plus Vb square. And you see here there is a relationship between Va and Vb. So you have an option. You can go for finding the velocity of B first and then velocity of block A, or we can do it otherwise in this manner. Say Va can be written as minus Vb tan theta. We can write it in this way. So you have an option. So if I choose this option, that means if I try to express everything in terms of block A, so I can say that Va square plus Vb square essentially means that this is Va square cosec square theta. Correct? So you see this is representing your kinetic energy at state point 2. Since at state point 1 everything was at the condition of rest, I can therefore say for me delta t, the sum delta t, this becomes equal to Va square cosec square theta. Now if you go and put all these equations, I mean to say you have this 4 sin theta term here, the work done. Then we have just seen that the potential energy here, if you just note that what is the potential energy, you need to remember that your block B is moving on the horizontal path, so it does not have any potential energy. Only potential energy is because of block A. And when it is coming at position 2, what is position 2? Position 2 is this arbitrary angle, correct? When this rod is in this position, this is now my position 2, correct? So Vg2 will be equal to how much? This is y, means 0.4 cos theta. So I can therefore say that the change in gravitational potential energy, I can write this is delta. Okay, I first write this as delta t plus this. So I say this is Va square cosec square theta, cosec square theta. Then you can write from here that it will be the change in the gravitational potential energy for block B. So it is Vg2 minus Vg1 for, Vg2 minus Vg1 for block A. Now Vg2 minus Vg1 for block A, that means I write it like that. This is Vg2 minus Vg1. Vg2 minus Vg1 for block A, because for block B everything is 0. Okay? So it means that you see how your problem can get complicated. This becomes 4 sin theta, it is equal to Va square cosec square theta, and Vg2, you see this becomes equal to, I can take the 2 kg mass as common, so I can say 2g I can take common. So taking this 2g common, I just consider the height. The height is at position 2, it is how much? That is 0.4 cos theta. Okay, this is 0.4 cos theta. And at position 1 it is how much? It is 0.4. So you see, this is the thing. So ultimately what I can write from here is something like this, that your Va square cosec square theta, that is the velocity for block A, I try to express it in any angular function, it becomes equal to how much? It becomes equal to 4 sine theta. Then this becomes plus, this means it is becoming 0.8 g. Then it becomes minus 0.8 g cos theta. So you see, ultimately what you can write is something like that. You can say VA square divided by this thing. So it becomes therefore 4 by sine theta, correct? Plus it becomes 0.8, I think I made a mistake, sorry, it is not 4 by sine theta, it will be 4 sine cube theta. So sine cube theta, then it becomes plus 0.8 g sine square theta, and then it becomes minus 0.8 g cos theta by cos theta into sine square theta. So we can say sine theta, sine square theta into cos theta. So you see, everything is expressed as function of theta. So here, of course, if you put theta equal to 90 degree, you should get our answer. What answer we have said? Say if you put theta equal to 90 degree, what happens here? Say in this equation, if I put theta equal to 90 degree, what will be the case? It gives me that VA square, that becomes equal to 4 plus 0.8 g, right? So you know that 0.8 g, if you just recollect, this is 0.8 into 9.81.
That's a 3.4.
Yes, that same 11.848 square root will give us 3.442 meter per second. So you see, this is how, you know, your velocity for block A is calculated as a function of theta, right? Exactly in a similar manner, since you know the relationship between the velocities for block A and block B, you should be able to getting the value of VB from this equation. And now you try a graph showing you the angular variation, how your velocities are actually, you know, varying with theta. You can very easily calculate it from there, and also from there you can find out at what position your velocities can become maximum or minimum. Say all these things are therefore, you know, are interrelated from there. So you can calculate all these types of, you know, the queries. You can answer to all these types of queries by calculating the velocities for both the blocks at any intermediate position you can think of. So you see, this problem can be made little bit tough if we take into contribution. You see here, Miriam sir has actually made your life very simple by providing these two simple geometric configurations. But you know, DN sir is not that gentleman as Miriam sir is. He is a very, you know, unkind fellow, an obnoxious fellow. So he will put you on in all sorts of troubles. He will ask you that you put this thing and find this variation. So in that way, I'm just joking, but you see, these are the things that you can think outside of the box and can analyze your problem. Okay, so this is the way we can deal with this situation. So I think you have understood. I give enough time here to analyze this problem, showing you the, you know, the how the what is called the multiple masses can be tackled. Now we will end our today's class by taking our last problem, which is going something like this. This is our next problem. Again, this is multiple masses. The number of masses has been increased from 2 to 3. So 1, 2, 3. This is the way I have gone. So you see here, this is a, you know, a mechanism. It said that earlier problem we did not have springs. So now we are having springs. The two springs, yes sir, বলুন।
স্যার আমাদের B3 এরপর সেশন আর নেই স্যার, ওটা ক্যান্সেল হয়ে গেছে, মানে টিকেবি
আচ্ছা
স্যার।
আচ্ছা আচ্ছা, বাহ, very good. So it's a very nice important news that you have provided to me. তাহলে আমি একটু হালকা পেসে যেতে পারি, ঠিক আছে, নালে আমাকে একটু হয়তো তাড়াহুড়ো করতে হতো। থ্যাংক ইউ ভেরি মাচ বাবু, তুমি এটা বলাতে। শিওর তো তোমাদের ক্যান্সেল হয়ে গেছে তো?
হ্যাঁ স্যার।
আচ্ছা, পরে আমাকে আবার টিকেবি স্যার বলবেন না তো যে স্যার আপনি ছাড়েননি, পারলাম না আমি? হ্যাঁ দেখো,
হ্যাঁ টিকেবি স্যার অ্যানাউন্সই করেছেন।
আচ্ছা ঠিক আছে, ওকে, থ্যাংক ইউ। তাহলে দেখো, let us now come and spend some time with this problem. Let us solve this problem together. তুমি আমি সবাই মিলে এই প্রবলেমটা করবার চেষ্টা করি। This is the last problem of today's class, where we are having number of masses is more than 1. In fact, it is 3. N equal to 3. The total number of masses is 3. দেখো এখানে কি লেখা আছে, the two springs each of stiffness k, both the springs are having the stiffness k, that is equal to 1.2 kilonewton per meter, are of equal length, okay, and undeformed when theta equal to 0. Acha, so when theta is equal to 0, obviously what would be the configuration? So let me draw it here itself. So this would be the configuration. So the spring length here, then the spring, I show it with the black pencil, not the spring, I just show the straight lines. So you see, sorry, so we see from here that coming like this would be the length of the springs, right? So this is one length, this is from this end, this is another length. So naturally the two lengths are equal, correct? When theta is equal to 0, because that is the position when theta equal to 0. Acha, if now the mechanism is being released from the condition of rest in the position theta equal to 20 degree, oh my god, so from this position theta equal to 20 degree, entire assembly is released from the condition of rest. So theta equal to 20 degree is this condition, is this state, suppose this is serving me the initial state point, or I can call it as state point 1. Determine its angular velocity theta dot when theta equal to 0. So when theta equal to 0 means, again you see this is the position, again you know this is the position that I am trying to I am actually looking at. So this is, I can consider as my position 2, that is theta equal to 0. The mass of each sphere is being given 3 kg, okay, and treat these spheres as particles and neglect the masses of the light rods and the springs. Okay, acha, so we do not have to take, you know, this mass of this rod, okay. And the second thing is this, we assume, though it is not very clear, but you see that it is assumed that the entire assembly is in the vertical plane, though I think it should have been mentioned. Because if there is no vertical plane action due to gravity, of course then the entire thing would be in the horizontal plane, and in that case the friction would have come into the picture, all these things are there. So that's why it is assumed that the entire assembly is in the vertical plane. Still, I think it should have been mentioned, or you need to guess from this analysis. So we need to calculate the angular velocity theta dot. So this time we need to calculate the angular velocity when this will be equal to 0. Treat these spheres as the particles and neglect the mass of the light rods and the springs. Very good. So therefore, again you see, we just write the equation and we note here that there are no forces, because if you see that there is no bearing friction here, in the bearing there is a chance that frictional moment may act. Now since the support reactions here, if you see, if you dislodge this system, consider this system dislodged, then obviously here the support reactions will come into the picture. All these things you need to write in the exam. So you see here the support reactions are attached to the non-movable point O, because the point O is a fixed point. The other day I was mentioning when the work done by the forces can be zero, I said that there is a category where the support, I mean to say the forces may be attached with the non-movable or immovable supports, if you recall our last class. So here you see there will be bearing reactions, both in these horizontal and vertical directions. I can resolve it and show it. But I note, since they are attached to the point O and the point O is not showing any displacement, right? Because it is not having any moment. Why it is not having any moment? Then otherwise this rod cannot rotate. So the rotational degree of freedom is open here. So it means that there should not be any moment that is acting at the bearing of point O. So it means that the work done by the support reactions here will be equal to 0. Why? Because they are attached to the immovable support points, and due to that there is no displacement whatsoever of the point of applications of the forces, I mean to say the support reaction forces. As a result, they are not contributing anything to my work equation. Or in other words, the support reactions come and under the reactive or non-active force category. So now if you see, after analyzing all these things, all this you need to write in the exam, correct? Now you see that what you notice is that apart from this spring and the gravity, there are no other active forces acting on your system. Understand? So it means that I'm not now using the summation sign, because that makes the notation complicated for me to make you understand. So I use the unsummed notation, but please keep it in mind that I am applying it for this group of particles. So actually the sum means there is a sum in front of everybody. That means you need to sum the kinetic energy, potential energy, everything here, right, for all these three masses. So I therefore note that since there is no other external force acting on the system, I therefore can write from here that the total energy is constant here. So I can say T1 plus Vg1 plus V1 must be equal to T2 plus Vg2 plus Ve2. Correct? Now, if you start with writing this equation, marks will be deducted, because you need to give the explanation that why this equation is going to be true. Okay, so these are some of the things which I am not writing every time in the board, but I discuss it in the class. So therefore, you have to answer these in this manner. Everything you need to justify in 1 or 2 sentences, not more than that. So you see, this is what we can start with. Now we note that if I consider this position 2 as my datum, I take this as my datum. That is the thing that we are getting. And we note from here that when it is coming to theta equal to 0, it takes this geometrical shape. That means springs, they attain their normal lengths. See, this is the 2 lengths of the springs were equal and uncompressed or unextended at this position. So these are therefore the natural length of the springs. So naturally at situation 2, what I find is that the V2, which actually represents the sum of V2, that means since here you are having 2 springs, you need to calculate the elastic potential energy for both the springs. So actually there is an invisible sum in front of every term here. So we note from here that I say since it is here, it is in the natural length position. So I find that the V2 for all the springs is basically equal to 0. Secondly, we note at position 2, you see these two masses are coming on the datum line. So therefore, the gravitational potential energy will be only due to M, because at that position then it will be pointing in this, so it will be in this position, right? And this 2 will be here only. This 2 will be here only. So since this 2 will be here, there is no gravitational potential energy for these two masses when they come to this position. However, it has this position, so it needs to be calculated the gravitational potential energy at this. Also, it is mentioned that when we release this system from the condition 1, theta equal to 20 degree, we note that here everything was released from the condition of rest. So it means that your T1, this term, they must also be equal to 0. So now we need to have some, the task, little task. What is that little task that we are going to get? Firstly, now I just reassemble my equation. States that Vg1 plus V1, actually all are sum, V1 basically becomes equal to T2 plus Vg2. The only gravitational potential energy, in fact, had there been no third mass, this would have been also 0. If this third ball was not there, you see, this third ball was not there, had that been the condition, then your Vg2 would have been also equal to 0. But in this case, we have the third ball, so we cannot write like that. Now we see from here, just see that if it is in this position, let me first try to calculate the positions of all the center of masses here. These are particles, you need to consider them as the particles. So what we see that if this is going to be theta, right, then this must also be going to be equal to theta. So the position of this 3 masses at position 1 from this datum line will be how much? See from here, this will be one height. I can call this as height 1, H1. I call this as H1 height. I call this as height H2, the second mass. I am arbitrarily calling them itself 1, 2, 3, right? The numbering I am doing. So this is H2, we can say, and obviously this one will represent my H3. This one will represent my H3. That means this height, this height, H3. Okay. So I can therefore say that I can make these calculations. H1 is equal to plus, because it is above the datum. How much? This is 0.25 meter. The radius is 0.25. So I can say this is 0.25 sine theta. This is 0.25 sine theta. H2 becomes minus 0.25 sine theta. And H3, that becomes equal to minus 0.25 cos theta. Okay, so we see all these terms are written in this manner. All the terms are written in this manner. Theta being equal to 20 degree, of course. So we see that when I am trying to calculate Vg1, since all masses are equal, actually it is mg into H1 plus H2 plus H3. And when you are doing this sum, you see these two are getting cancelled. It is because that these two, if you consider these two, their center of mass is here at the position. So if you take the total potential energy of these two masses, again you see that they get cancelled. So you see this problem is pretty interesting, because when it is coming to position 2, you see these two are, their potential energy is 0. Only I have this potential energy, and also at position 1 these two potential energies are getting cancelled, and I am having only this potential energy. So the entire problem, the change in potential energy is driven by due to the changes potential energy of this third mass. So you need to analyze these problems. Take some time at your home, try to analyze the problem you are solving. So you will get many things coming out from the statement of the problem.
স্যার
So
লাস্টে
last,
পোটেনশিয়াল এনার্জির এই ব্যাপারটা একটু বলবেন,
হ্যাঁ বলো কোন জায়গাটা বলতে হবে?
যেটা আগে একটু আগে ডিসকাস করলেন যে
আচ্ছা,
পোটেনশিয়াল
একটু
এনার্জি।
আগে যেটা ডিসকাস করলাম, আমি কি বলতে চাইছি দেখো, VG1 means what? It is the sum of the gravitational potential energies of all these three terms, correct? তাহলে মানে কি, তার মানে হচ্ছে because all your masses are equal, so this VG1 then essentially means what? M into G into H1 plus H2 plus H3 at position 1, correct? This is the thing, this is at position 1, and this we are doing it for position 1, this analysis we have done it for position 1. So you see that if you sum them, this VG1 term, if you are summing them, what you are getting, you see this H1 plus H2, they are becoming 0. It is because that these 2 points center of mass is only at the origin. So the center of mass of these 2 will be always at the origin, which means whatever be your position, there is total potential energy of these two masses, sphere 1 and sphere 2, right? Their sum is always going to be equal to 0. So you have only the third mass that is surviving. So that is what I was telling, that it is very funny, because we have seen that when it comes to position 2, this 2 comes on the datum line, so automatically their potential energy will be 0. So only potential energy surviving is the third mass, and here at situation 1, position 1, there also you see the total potential energy of these 2 becoming 0, and only surviving potential energy term is this one. So the entire problem, you see, the change in the gravitational potential energy is driven by the potential energy of the sphere 3. So therefore I can write, you understand what I am saying? So I can therefore say that, okay, so I can therefore say that it should be equal to minus mg into H3, and H3 is minus in fact, so that is why it is minus, into 0.25. So you see this is into 0.25 into cos 20 degree, because theta is being given to be equal to 20 degree. Okay, and when theta becomes equal to 0, you see the H3 term becomes entirely, you see, minus 0.25. So I can say here at this, I can write this will be minus mg into 0.25, right? I write it in this way. So that is the VG2 term. Okay, now we are coming to discuss the VE1 term, the total change in the elastic potential energy. This is somewhat little bit challenging. You have some geometries to solve here for this problem, correct? So let us now focus onto this. So for doing that, I like to draw the circle. Sorry, no. Okay, so this is the circle that I am drawing. Okay, let me take it out here, little bit downward in this way. Okay, so this is the circle that I am drawing. Now we see that, say, this is the position for the position 2, and for position 1 we see that sorry. Actually, it's difficult to control in the tab to draw the line. So let me try my best to show you. Oh my God. To show you the line which I am drawing. That's why for some complicated problems, I actually pre-draw the figures. But this time I do not have the time to do it for you. So this is one position. This is one position. And we need to take the point here, which is vertically above it. Just consider like this. Okay, so let me give some names to these locations. Say I call this point as P, I call this as Q, I call this as R. So what I am interested to know in actually these lengths, because this will define my current, sorry, this will define my current, don't mind for such, it's not going through this accurately. Anyway, so you see this is the thing. And we know that this is an angle, let us call this angle as theta. So actually I need to calculate these two lengths, RQ and your RP, when I know this OR. OR, you can take it as 0.25 meter, this 0.25. So see, this is theta. So if this is theta, if this is going to be theta, then of course this angle is going to be 90 degree minus theta. Since this is an isosceles triangle ORQ, I can say that these angles will become equal to 45 degree plus theta by 2 each. That means this one will also become 45 degree plus theta by 2. Right? You understand? If you do not understand, please tell me. Is it okay? Is it okay?
Yes, sir. Yes, sir. Yes, sir.
Very good, very good, very good. So if this is now known to be, the RQ, then this is known, OQ is known or OR is known. So I just apply the cosine rule to this and can say that RQ, the length of one spring element, will be equal to 2 times OR means 0.25, 2 into 0.25. কেউ যদি না বুঝে থাকো বলবে কিন্তু 2 into 0.25 into cos of 45 degree plus theta by 2. You understand what I have done? I have dropped a perpendicular from the point O to this manner, this way, and this is perpendicular, sorry, this is going to be perpendicular, and thus RQ will be bisected here. So just calculate 0.25 cos 45 degree plus theta by 2 will be this length, or from here to here this length, double of it will represent RQ. Means that it will become 0.5 cos of 45 degree plus theta by 2. Okay? So you can calculate this RQ when theta is equal to 20 degree. How much it is you can calculate? For theta equal to 20 degree, it is going to be 0.5 cos 55 degree. So you can very easily calculate this one. Right? And we know that PR also we can do it in this way. Say if this is theta, then this must be theta, this must be theta, this is theta, this is 90 degree. So this entire angle becomes 90 degree plus theta, which means these angles will be now 45 degree minus theta by 2. And this will be also 45 degree minus theta by 2. Correct? So in that means, it means that PR is going to be equal to following the same. I can write, it will be 0.5 cos of 45 degree minus theta by 2. So it means that it becomes equal to so much of meter, and it becomes equal to 0.5 cos of 35 degree so much of meter, because theta is 20 degree. So you see, the dynamic length of the springs have been calculated, right? And if you put in these expressions theta equal to 0, then definitely you will be getting the uncompressed length of the spring. The uncompressed length of the spring is what? Both of them are equal. So putting theta equal to 0 into this or into this, I say the uncompressed length for each spring becomes equal to how much? It becomes 0.5 meter. 0.5 cos 45 degree meter. So it becomes 0.5 cos 45 degree meter. Correct? So that would be the uncompressed length of the individual springs. So I can say therefore, I just add page here and can say like that. I can say from here that the delta VE, so I write the equation delta VE, sorry, not delta V, I'm not writing it delta form, I'm writing it 1, so VE1, so I say VE1, so oh my god, so I say V1 will be equal to how much? Please solve with your own calculator, everyone. We should check our answer. V1 will be equal to how much? V1. V1 means for this spring and for the second. So two springs we need to calculate. How much is the stiffness of the spring being given in the problem? You see, K value is being given to be 1.2 kilonewton per meter. Means essentially it is 1200 Newton per meter. We write like that. So half kx square or half k delta square is the V1. You remember? So half k means it will be 600. So I can therefore write it in this way that it will be 600 for both the springs into. Now we need to calculate the square of the extension and compression for both the springs. Now I do not have to bother about compression or extension like that, because this is 0.45 cos theta, 0.5 cos 45 degree, and this is, you see here, it is 0.5 cos 55 degree. So even I can take this 0.5 square also common. So I just made some adjustment. I say it is 600 into 0.55 square, right? Taking, 0.55 na 0.5 square. Oh, kichu bhul korchi. So it is 0.5 square, 0.5 square. So write like that into. It will be how much? It will be, you see, cos 45 degree. For one, it will be cos 45 degree minus cos 55 degree square plus it will be cos 35 degree. One will be compressed and other one will be extended, minus cos 45 degree square. Okay, so that will be the total V1 that we have. And since we know that V2 is 0 because the spring attains here, so already we have put V2 equal to 0, so we don't have to bother about that. So I see that on the left hand side everything is now known to me. Now comes the kinetic energy term. So we do bit by bit kinetic energy term. Kinetic energy term, how we are going to calculate? See, the entire rod, entire assembly is basically rotating with respect to the point O. So if I assume that the angular velocity here is theta dot. This is the angular velocity, theta dot. Okay. So if this be my angular velocity, then I can say everyone is having the velocity 0.25 theta dot. Everyone is having this velocity. So I can therefore say that T2, I can thus say that T2, the kinetic energy at position 2, you see that if I assume theta dot is the angular velocity, when theta is becoming 0, it is 3 by 2, because all kinetic energies are equal, 3 masses, so therefore 3 by 2 into m. M is how much for us to this problem? Now m is being given to be equal to 3 kg. 3 kg is being given. So we need to write that 3 kg term, right? So here actually, I have incompletely written this equation. So m is here. We need to put m in this equation 3 kg. Okay. So in these two terms. So thus we can say that can somebody give me what is the answer to this? Or should I have to do the calculator of my own? You should be able to solve this and calculate how much is this coming out to be? কত আসছে বলো?
4.557.
4.557 joule should give the unit. ঠিক আছে? প্রত্যেকে করেছো? প্রত্যেকে কিন্তু করো।
হ্যাঁ ঠিক আছে স্যার।
Okay. Okay. So that is the thing. This is the V1, then my T2 comes out to be is equal to how much? So it should be 3 by 2 into 3 into the velocity. The velocity is 0.25 into theta dot square. So it means that it is 9 into 0.25 square divided by 2 into theta dot square. Right? So this is the thing. So that gives me the thing called T2. Now I come and apply the equation. So the equation is what? The equation is, this is minus mg, so 3 into 9.81 into 0.25 cos 20 degree I can write. So I say it is minus 3 into 9.81 into 0.25 into cos 20 degree, that is this term. Then to it we need to add this 4.557. So this is 4.557 is equal to, this term you have 4.5, I shorten it, into 0.25 square, 0.25 square theta dot square, and then I have the next term here, that is this, that is minus 3 into 9.81 into 0.25. So I write this is minus 3 into 9.81 into 0.25. My objective is to find out theta dot square. So you can say from here that it is 3.3 into, I just simplify, 3 into 9.81 into 0.25 into 1 minus cos 20 degree, correct, plus 4.557. Okay, this should be equal to 4.5 into 4.5 into 2.25 square into theta dot square. In fact, you can 1.25 you can cancel and can further say this is 3 into 9.81 into 1 minus cos 20 degree plus 4.557 turns out to be as 4.5 into 0.25
স্যার ওখানে একটা 0.25 ডিভাইড হবে 4.557 এ।
Oh yes, yes, yes. Thank you. এই তো দেখেছো, এইরকম মিস্টেক আমি ভীষণ করি। This into আমার নজর এদিকে রয়ে গেছে। So into theta dot square. Thank you. So how much is theta dot turning out to be? Solve this. Calculate the theta dot for me.
4.2166.
হ্যাঁ
4.166.
4.2166.
বাহ, চটপট ছেলে। 4.2166. So much radian per second. So this should be the answer, right? Now what was our problem number here? It was problem number how much? 3 by 151. So go to our book. 3 by 151. We are in that page only. তাই তো, কত আছে দেখো, 4.22 রেডিয়ান পার সেকেন্ড, তাই তো আমাদের কত বেরোলো?
4.2166.
ঠিক আছে, 4.2166 means 4.22 radian per second. So you understand how this problem is therefore tackled? So you can have a little bit of geometry being involved into your problem. For example, this problem is a very interesting one. খুব সুন্দর অঙ্কটা, ছোট্ট অঙ্ক, দেখো তার মধ্যে কত কিছু ইনসাইট আছে। So many intricacies are there which you need to step by step need to do these things, correct? Once you are habituated in doing it, then you see you will be getting that expertise. তোমার এই এক্সপার্টাইজটা কিন্তু এরকম ভাবেই তৈরি হবে, এমন নয় যে তোমাকে এই এক্সপার্টাইজটা আমি ডেভেলপ করিয়ে দিতে পারবো। So you need to practice and develop this thing in that manner. তাহলে বোঝা গেল, দেখো, how to handle the multiple masses in the work energy equation, and all the masses you need to understand they must be constrained. For example, এখানে কনস্ট্রেন্টটা কি ছিল? এখানে কনস্ট্রেন্টটা হচ্ছে all of them are connected by these light rods. That means all of them will have the angular velocity. It will be rotating in the vertical plane. So simply it will go on rotating in the vertical plane. Actually it will oscillate in this manner. তাহলে দেখো এখানে চ্যালেঞ্জিং কোয়েশ্চেনটা হচ্ছে কি? চ্যালেঞ্জিং কোয়েশ্চেন হচ্ছে when theta is equal to 20 degree, it is being released from this, up to what angle it will go before it again returns its journey in the opposite direction. That could be the thing, right? Another thing is that, say, for any angle position, calculate the velocity of the three masses or three spheres. From there, calculate the maximum velocity and at what position the velocity of the spheres will be maximum. So all these questions you can by yourself frame and try to answer them at your home. ঠিক আছে? So with this three problems I like to show, আমি এখানে যে কটা তিনটে প্রবলেম দেখালাম, all these three problems you see that I have tried to highlight the characteristics, individual characteristics for all the problems. হ্যাঁ, কি করে হচ্ছে যে ওয়ার্ক ক্যালকুলেট করতে হয় for non conservative, I mean to say other than spring force, gravity force যদি থাকে, অন্য কোনো ফোর্স থাকে, how you are going to calculate the work done by that, that is number one issue. Second issue হচ্ছে if there are multiple masses, how to tackle the multiple masses with the help of the constraint equations and all this. So this shows you know the how you need to step by step analyze your problem and solve it. So if you have any question, feel free to ask me, but before that I just at this point like to stop my recording of the class. You can go on recording your class, of course. For me this is the end of the class, so I just stop my recording here and open this discussion to you for any queries or any questions or any suggestions you want to get. You can ask me, no problem.
আমরা প্রবলেম সেট সলভ করব, একটু যদি বলে দেন।
কোনটা গো?
এই চ্যাপ্টারের জন্য, বিকজ আই থিঙ্ক বলেছিলেন যে স্প্লিট করা আছে চ্যাপ্টার দুটো।
আমি বুঝলাম না তোমার কোশ্চেনটা, কোনটা সলভ করে দেবো বলবে?
যে আমার মিডিয়াম থেকে কিভাবে সলভ করবো আর কি, বিকজ আপনি বলেছিলেন যে দুটো চ্যাপ্টার আর কি ভাগ করা আছে।
ও আচ্ছা আচ্ছা, না না, সলভ তুমি দুটো চ্যাপ্টারকে একসাথেই করতে পারো, দ্যাট ডাজন্ট ম্যাটার। তুমি প্রথম চ্যাপ্টার 1 এতেও সমস্ত অঙ্ক তুমি এই ইকুয়েশন দিয়ে অ্যাপ্লাই করে দেবে। আমরা তো প্রথম অঙ্কটা যে করেছি, এই যে আমরা প্রথম অঙ্কটা, the first problem that I have shown, this first problem is taken for first chapter, from the first chapter. Actually in this problem, Miriam actually thinks that we have solved this problem by using the equation 1u2 equal to delta t, কিন্তু আমরা বলেছি যে না, আমরা ওই রকম ভাবে করব না, because that leads to confusion. একবার 1u2 equal to delta t করছি, আরেকবার 1u2 tilde delta t plus delta vg plus delta v করছি, কিন্তু যেহেতু সেকেন্ড ইকুয়েশন has lots of advantages, because এই যে অ্যাকচুয়ালি আমরা স্প্রিং এর যে ওয়ার্ক ডানটা করলাম, এই স্প্রিং এর ওয়ার্ক ডানটা তুমি প্রায় করতেই পারবে না, বা ভীষণ কঠিন একটা ইন্টিগ্রেশন হবে had you followed the first method. Say the last problem that we solved, এই লাস্ট প্রবলেমটা যেখানে আমরা সলভ করলাম, as the spring gets deformed for as it, the assembly is rotating from theta equal to 20 degree to this position, you see the dynamic length of the spring, they changes, and every time you need to track that dynamic change of the length of the spring, and then you need to calculate the extension, and then you need to calculate the work done. It's a hell lot of a problem. Mane sometimes the integration becomes so awkward that your problem becomes too lengthy. It becomes the problem of mathematics instead of becoming the problem of mechanics. So in order to avoid such kind of awkward integration, দেখবে এগুলো মেরিয়ামের বইতে লেখাও আছে। Yeah, if you go just read the book of Miriam, you will find that everything is written over there, and you see that in that case we can avoid that awkward integration just by merely recasting our work energy equation into the second form. So that's why my suggestion to you is that you solve the problems from chapter 1 and chapter 2 of the work energy, these two chapters are there, and try to solve the problems from both the chapters using only one equation, that is 1u tilde 2 equal to delta t plus delta vg plus delta v, means that you are taking your spring, if there is any spring at all within your system, you need to include those springs into your system. That means your system, for example, the last problem that I show here, these springs, these springs, I mean to say this spring and this spring, they have been taken into our system. So I have considered the entire assembly into my system, right? And thus we see that we write the equation in that manner. And since in this case I explained that there are no other, the external forces, external active forces are there very much, but no other external active forces, underline the word active, no other external active forces acting on your system, I therefore write the equation as delta t plus delta vg plus delta v equal to 0, or in other words it is t1 plus vg1 plus ve1 equal to t2 plus vg2 plus ve2. I repeatedly say, if you start writing the equation as I have written here, if you follow me blindly and start from here, nothing writing anything before that, then you will not be getting, if your entire work is correct, even after you will not be awarded the full marks, because the examiner will first put the question mark why you have written that equation, t1 plus vg1 plus ve1 is equal to t2 plus vg2 plus ve2. Is this going to be true in every case? Obviously the answer is no, right? So you need to explain in 1 or 2, you do not have to write any history geography. Only thing, minimum, max to max 1 or 2 sentences you need to write explaining why you have written this step. Is that clear, Mr. Vishal Roy?
Yes, sir.
So it should be clear to all of you.
হ্যাঁ স্যার।
ঠিক আছে তো?
Yes.
হ্যাঁ, আর যদি if you have still